Hello to everyone. Thank you for the invitation to participate in this workshop. My name is Sebastian Richiano. I will show you an example of Holocene Bridge and the evolution of this ridge in Argentina. Marine quaternary deposits are well developed and outcropped in all the Patagonian coast and also in Buenos Aires province. And even when the stratigraphy, geomorphology, and paleontology are more or less quite well developed, the detailed sedimentological studies are scarce in these deposits. So the objective of this presentation is to show you an example of a detailed sedimentological study in one of the Holocene deposits. The study area is located at Rio de la Plata estuary, here in Buenos Aires province. This is Argentina, Uruguay, Brazil. The Rio de la Plata estuary. This is the San Borondón Bay, where the Holocene deposits are very well developed and outcropped, in this case, in the intersection of the provincial road and the artificial channel. This is the Holocene Bridge, where we had worked on traditional sedimentological studies, 3D ochre modeling, and isotopic geochemistry. The traditional sedimentological studies are constituted by 14 sedimentary logs, detailed sedimentary logs, all distributed all along the study area. Then the paleoenvironmental analysis, which allow us to divide the tidal flood in the base of all the deposits. Then the main body of the are constituted by the ridge, divided in two, the sand ridge and the shale ridge. To the continent, the development of lagoon and washover phases, and to the east, the marsh deposit. I will concentrate this presentation just on the ridge, which you can see that are subdivided in 11 clinothems by these surfaces that are clinoforms, yes? And the numbers from 1 to 17 and different samples that we use for the characterization into the ridge. And the samples are concentrated on some particular surfaces that are very well exposed in the field. So the sandy ridge has this aspect. The first two clinothems constitute the sandy ridge. It's quite complex, the internal configuration. You can see here, this is the main surface or one of the clinoforms, and then the internal surfaces shows a complex sedimentation. This is an example. 90% of the material is quartzitic sand, very typical trace fossils of shallow environments. In this case, this is Macaron igneous. The shale ridge is quite similar in architectural development, but 90% of the material are shells, particularly mollusk shells, mainly bivalves. So most of this deposit is directly carbonatic deposit. With the 3D ochre modeling, we could characterize and measure some aspects of each clinoform. Some of them in the field are very well expressed, and it's easy to take some measures, but the others, only after the reconstruction with the model, we could measure some aspects like the dipping angles, the horizontal extension, and the direction of progradation. Two main geometries have been recognized, sigmoidal geometries, and some of them are straight. We measure also in some of these surfaces near the top of the surfaces with the limit of the ridge with the differential GPS. For isotopic geochemistry, we use a very strict method. We only use some particular samples very near the top or on the surface, just one taxon with a very strict taphonomical analysis. For example, for one age, so one dating is constituted by 400 to 600 shells. No, that it's a lot. This method allow us to obtain a very constrained age of the ridge, the tidal flat depositing near 6 kilo-year, and then all the ridge, the progradation was between 5.2 and 3.9 kilo-years. This represents that more or less in 1,300 years, we have 300 meters of ridge progradation. With the isotopes of carbon and oxygen, we could interpret the temperature values and the salinity of the water during the deposition of each of the samples. So we have that the temperatures have an average between 18.5 and 21.5 Celsius degree. And in general, all the ridge was developed under normal salinities. I will start the discussion with the salinities. If you watch the present influence of the Rio de la Plata in the salinities of the coastal sector in Argentina, Uruguay, and Brazil, you can see that in winter, when the discharge of the river is the largest, the influence of this river in the coastal salinity reach the 26th southern latitude, yes? But in summer, with a small discharge, the influence reach only 32 southern. So if you want to have a place or to watch a place where all the year you have normal salinities, you have to go northern than 26 southern latitude. Considering the temperature, this is the present day distribution of temperatures in the sea. This is the study area. This is the distribution of temperature for summers and winter. And you can see that today we have temperatures between 12 and 22 with 17 more or less on average at this locality. But if we think where today are more or less the same conditions as we measure for the Holocene deposit, we stay here with average between 18.5 and 21.5 Celsius degree. You have to place in southern Brazil to obtain more or less same temperature data of water. So finally, the surfaces versus temperature. If we compare what happened with these changes in temperature, we have two different groups, temperatures above 20 Celsius degree and below 20 Celsius degree. And the surfaces of the clinoforms are really different in the two groups. No change the dipping angle, the geometry, and the frequency in the surfaces. So we could interpret that this temperature control the frequency and the intensity of the mechanisms that generate clinoforms like storms or major events of beach erosion. We have discussed the temperature, the salinity, but what influence all of this? The main controlling factor is this system of oceanic currents. The Brazilian current is warm and flows to south. The Malvinas current is cold and flows to north. And this is the confluence zone. This system changed its position during the Holocene to southern. The Brazilian current was stronger than today. So all the Buenos Aires province and maybe northern Patagonia have been influenced on warm waters. The conclusions are that the pit reached the paleo-pit between 5.2 and 3.9 kilo-year-BP. The temperature and salinity conditions are similar to other schisters today in southern Brazil. There is a direct relationship between sea surface temperatures and the geometry and frequency on the surfaces. We stress that the strong activity of the Brazilian current during the mid-Holocene thermal maximum enabled excellent conditions for the development of carbonate warm beach similar to that occurring at tropical and subtropical areas nowadays. And this study provides an example of the strong changes occurring in coastal environment as a result of climate change similar to interglacial periods in Lake Quaternary of South America. Thank you for your attention.